This video is going to go ahead and introduce you to radicals, cube roots, square roots, and index values that are higher than 3. Alright, so let's go ahead and start with a square root. So a square root symbol looks like this. And when you see this symbol, it means what times itself. So what same number times that number gets you the number that's inside the radical. So here's some radicals down here, some square roots, and these are called perfect squares because the number that is inside the radical has a perfect answer. It's not a decimal. So for example, the square root of 1. The answer is 1 because 1 times 1, this number, times itself, gives you the number on the inside. So the square root of 4 is 2 because 2 times 2 is 4. Square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16, and etc. So again, these are called the perfect squares. So notice all of these are positive because if we had, for instance, the square root of -4, it wouldn't work. We couldn't get a real number answer because 2 times 2, that's 4, so that doesn't work. And -2, they have to be the same. So -2 times -2, that's also 4, so that wouldn't work. So you can't have a negative inside if it's square root. So the square root of a negative number is not a real number. So that's what we would write in this section. Later on in this class, we'll talk about how the answer to the square root of -4 is 2i. That's only if we're working with complex numbers, so if that's confusing to you, don't worry about it till later. But you're going to write not a real number when you have a negative inside the square root if we're working with real numbers. So if we take a look at number 1, it says, what is the square root of 9 hundredths? So if we break this up, we know that 3 times 3 is 9. And then we know that 10 times 10 is 100. So the answer to this would be 3/10. Because we know when we multiply fractions, we go straight across. Now if we check this with our calculator, so please take out your calculator, make sure you know how to do this with your calculator. You're going to click the second button, or whatever, it's light blue on my calculator, whatever this is, so you're going to click on that. Again, these are the directions if you're using a TI 30x2s here. And then you're going to click the button with the x squared because in the background in blue it looks like our square root, like that. And then we're going to type 9, and then you're going to click ABC because that's the fraction bar, and then 100. And that is asking the calculator to figure out what times itself is 9 over 100. You get 3/10, which is what we got here. Now let's do it again. So second, and then click the square root button. This time, instead of the ABC button, do the divide button. This time, if you use the divide button for a fraction, your answer is going to be given to you as a decimal, because 3/10 is 0.3. So if I change it, the decimal to a fraction, I click second and then the FD button over here. There it is. So 3/10 is also the right answer. So it depends if the directions specify. So since this problem did not, either one would be okay. All right, let's take a look at example 2. So it's asking us for the opposite of the square root of 4. So the square root of 4, what times itself is 4? That's 2. And then you bring down the negative. So that negative is not inside the radical, it's on the outside, so it just gets brought down. So if we're entering this in the calculator, here's the negative button. So negative square root of 4. I get -2. All right, let's try number 3. This is saying what times itself is 36 hundredths, so 0.36. So if that sounds confusing to you, then remember we can change. You've learned in a previous math class that this is the tenths place and this is the hundredths place. So to convert 0.36 as a fraction is 36 hundredths. So some people think better if it's in a different form, a fraction form, because now it looks just like this one. So now I can ask myself what times itself is 36, so 6 times 6, and what times itself is 100, 10 times 10. So the answer is 6 tenths, but 6 tenths, if we simplify it, is 3/5. So our answer is 3/5. So now we check this with our calculator, and we do the square root of 0.36. We get 0.6. So if I change that to a fraction, since I have a fraction here, it is 3/5. So our answer is correct. Now another way to do it is to just think about that 6 times 6 is 36. But if these were both 0.6 times 0.6 would be 0.36, because we know that when we multiply with decimals, we move the decimal however many times there are place values after the decimal. So since there's 2 numbers after the decimal, it would move it over twice. All right, let's go ahead and take a look at number 4. So this is saying what times itself is 16b to the 6. So let's break this apart. Let's do the square root of 16 first. So I know that 4 times 4 is 16. And if I put a b here and a b here, that would make 16b to the 2nd. If I put a 2 here and a 2 here, that would equal 16b to the 4th. I need a 6. So if they were both 3, then it would work. So the answer is 4b cubed, because 4b cubed times 4b cubed would get us the value in the inside. So the trick is when you have an exponent, you're going to take whatever number's right here. So as you can see, like in this problem, it's a 3. So when there is no number right there, it's going to be a 2. So if it doesn't have a little number, all of these don't, there's like an imaginary 2 there. So you're going to take this 2, or whatever number this is, and ask yourself, how many times does 2 go in a 6? So 2 goes in a 6 3 times. So that's another way to figure out the exponent that goes here. So again, you take, this is called an index, we're going to write it down here soon, and divide it into the exponent, and that's how you get your answer's exponent.
All right, next we're going to talk about cube roots. So you will notice that there's this little number right here. There's a 3. That's called an index. We'll write it down shortly. But that is how we know that we want to know what number times itself this many times, so in this case 3, will give you the number inside the radical. So what times itself, in this case 3 times, gives you the number inside the radical. So if we take a look at example 5, we have the cube root of 27. So this is asking us what times itself 3 times. The same number times the same number times the same number will give us 27. So if you didn't have a calculator, you would do guess and check. So you would think of a number, whatever number you think it is, so in this case it's 3, and you would check. 3 times 3 is 9, and then 9 times 3 is 27. So that's how we know the answer to this one is 3. Now, if you have a calculator, the button on your calculator that does that, we've talked about it briefly before in this class, you're going to type in the 3 if you have the same calculator as me. If you don't, it could be a little different. So you're going to click on the 3, and then you're going to click the second button, and then this button right here. You're looking for the key that has the x and the little radical. So what it's telling your calculator is to make that little x number a 3. So if you want it to be a 4, you'd put a 4. And then 27. So what times itself 3 times is 27? And we got the same answer here. Okay, so let's go ahead and take a look at the next one. So this one says, what is the cube root of negative 125? So it's asking us what times itself 3 times would make negative 125. So it ends in a 5. I don't know. I'm going to go with, I think it's 5. And then 5 times 5 times 5. So 5 times 5 is 25. And then 25 times 5. So if you didn't have a calculator, you'd have to do it by hand like this and check. And then you could see, well, that would make 125. It's negative 25. So then I'm like, okay, well, what if I make them all negatives? Because they have to be the same. Well, then these two would make positive, and then you'd bring down the negative, and a positive times a negative would make negative 125. So you are allowed to have negatives inside a cube root. So that's what goes right here in our notes, is that the cube root of a negative number is possible. Whereas if it was the square root of negative 25, that would not be possible, because 5 times 5 is 25, and negative 5 times negative 5, that is also 25. So whenever this little number here is even, an even amount of negatives always makes positive. So you can't have, we don't want a negative number when we're dealing with real numbers inside the radical when this index number right here is even. So if it's not there, it's a 2. But since this one was a 3, it is possible. So negative 5. All right, let's try the next one. So this is saying, what times itself 3 times is 1/8? Well, if I piece this, or if I split this apart here, I know that 1 times 1 times 1 would get me 1. And then 2 times 2 times 2 is 8. And so that's how we know that the answer is 1/2. So now if we put this in our calculator, and we do the cube root, so we're going to click the 3, and then the second, and this button right here under the pi button. And we want to know what times itself 3 times 1/8. Now, please follow along with me, because this is a common mistake people make. Because there's 2 numbers in the radical, you want to use parentheses. So if you're going to use the divide bar for 1/8, then you're going to get an answer as a decimal, because it means divide. It actually divided the 2 numbers. Well, if you just convert it to a fraction, 0.5 is 1/2, the answer we got here. Now, if I do it again and I do the 3, and I click second, and then the button underneath the pi, and this time if I do parenthesis, and I use 1, and I use the ABC button, and then the 8, then it's going to give me the answer directly as a fraction, because that's the fraction bar, so it tells me I want a fraction as my answer. So again, you could use the divide or the ABC for a fraction bar, but this button would give you it in a decimal, whereas this would keep the answer as a fraction, depending on what you want. All right, let's take a look at the next one. So this is saying, what times itself 3 times is x to the 12th? So what times itself 3 times? So if I put an x here, and x here, and an x here, we've learned in this class when you multiply that you add the exponents. So that would make 3. We need 12. So if we make all of these 2, that would be 2, 4, 6. If I make all of these 3, that would be 6, 7, 8, 9, not enough. But if I make all of these 4, then when you add them all, it would make x to the 12th. So that's how I know the answer to this is x to the 4th power. Now we also talked about that we could also get the answer. So this is why the answer is x to the fourth. But all we have to do is take this index right here and divide it into this. So 3 goes into 12 4 times. So that's how we would know to split this up into exponents of 4, because it's 3 groups of 4. 3 times 4 is 12. Okay, let's try this next one here. So it's the cube root of negative 64y to the 6. So first of all, when this is odd, this is okay to be negative. So we have to think of what times itself 3 times would make negative 64. So if you didn't have a calculator, you would make a guess. So 4 times 4, negative 4 times negative 4 is 16. And then a positive times a negative is a negative. That's why it's allowed. And then 16 times 4 is negative 64. So I would know it's negative 4. And then if I use the strategy to divide, I could get 3 goes into 6 2 times. And then that would be our answer there. Now, we can also think of this as if I had y squared, and y squared here, when you add the exponents, you get 6. So we could just divide the exponent or think of it visually.